So for today's lesson, we're talking about finding angle measures in a polygon. So a polygon is a closed plane figure, and it's formed by 3 or more line segments, and those line segments are all called sides. And then each endpoint of a line segment is called a vertex. So you've got convex polygons and concave polygons. You learned about these probably way back when, but I'm not sure if you remember. A convex polygon is a polygon whose interior angles are all less than 180 degrees, and any line segment that contains 2 vertices remains inside the boundary of the polygon. What that means is if I were to start drawing line segments from vertex to vertex, not a side, but just across or in through the polygon, all of those line segments remain inside the boundary of the polygon. Inside the boundary of the polygon. That's convex. Concave doesn't do that. So what happens if I were to pick a vertex and start drawing line segments from vertex to vertex, all of those segments remain inside the polygon, but if I were to try to draw a line segment from vertex to vertex there, that line segment falls outside the polygon. So a concave polygon, silly definition, it's a polygon that's not convex, but really what you're looking at is any line segment can fall outside polygon. And that particular line segment that we're talking about in this case would be the one that's right here. Okay? Then we start classifying polygons. And polygons are always classified by their number of sides. If a polygon has 3 sides, you know it's called a triangle. If a polygon has 4 sides, it's a quadrilateral. Squares and rectangles are types of quadrilaterals. 5 sides is called a pentagon. 6 sides is called a hexagon. 7 sides, I've heard different words for it, but we're going to call it a heptagon. 8 sides is called an octagon. 9 sides is called a nonagon. 10 sides is called a decagon. I don't know why we skip 11, but it's an undecagon. And 12 is called a dodecagon. Well, at some point we start, getting numbers bigger than 12. So if n stands for the number of sides, then any polygon after 12 is just called an n-gon. For example, you might have, let's say, like a 15-sided figure, or a 15-gon, or a 21-sided figure, a 21-gon. Then we talk about regular polygons. And a regular polygon is a polygon that is both equilateral, all sides the same, and equiangular, all interior angles are the same. So we're both equilateral and equiangular. And your drawing is marked as such. The sides are all marked and the angles are all marked. The diagonal of a polygon is going to be any line segment that joins 2 non-consecutive vertices. Because if you join consecutive vertices, what you would be having is a side of the polygon. And we don't want the side, we want the diagonal. So we don't want that. We want to go across, whoopsie. We want to go across the polygon, non-consecutives, and then have a diagonal. So there's an investigation that is really good to do to understand the formulas that are going to be given to you next on your sheet. So if you've got this investigation thing, what we're going to do is talk about all of these polygons being regular. And we're going to draw all the diagonals from each vertex indicated, and then we're going to complete the table. So basically what happens, on this first picture we have a triangle, right? So we're dealing with the first one. We've got a triangle. We've got 3 sides. In the number of sides, there's 3 sides to a triangle. There's only 1 triangle that's formed. Well, the sum of the measures of the interior angles of the triangle is 180, because if there's one triangle formed, then one triangle times 180 degrees, right, because this thing here is 180 degrees, is 180. If you want to find a measure of an interior angle of that regular triangle, we know that if we take the sum of all of them and divide it by 3, we get each interior angle, and we should know already that each inside angle is 60 degrees. If we want to find the measure of an exterior angle, then all you would do is extend a side from the triangle and realize that the exterior would always be its supplement. So the way you're finding the measure of one exterior angle is you're saying that 180 minus 60, 180 minus the inside to get 120. And if there are 3 interior angles, there are 3 exterior angles, and the sum of those 3 exterior angles equals 360. So let's see if we can do this for the other figures. If we take the quadrilateral and we draw as many diagonals as we can from that one vertex, from this one vertex shown, we can draw, well, let me back up for a second. A quadrilateral, I should say, has 4 sides. When we draw that diagonal, we've made 2 triangles. Each triangle is worth 180 degrees. So 2 triangles at 180 is a total of 360. If we find a measure of one of those angles, it's 360 divided by 4, because there's 4 sides. Each angle measure is 90 on the inside. Then if we say, okay, well, if an inside is 90, then the outside is its supplement. So 180 minus 90 is 90. And if we happen to have 4 outside angles, 4 times 90 is 360. Go for the pentagon. Pentagon has 5 sides. If I draw as many diagonals as I can from that one side, I've created 3 triangles. Each triangle is worth 180 degrees, so 3 triangles times 180 is 540. If I divide that 540 degrees by 5 angles, each angle inside is 108. If I look for an exterior angle from the 108 inside, subtract that from 180, each outside is 72. And if there are 5 sides, there are 5 angles, so 72 times 5 gives you 360 degrees. There should be a pattern that you're seeing. Let's go for the hexagon. 6 sides. The number of diagonals drawn from that one indicated vertex is 4 diagonals, which gives, 3 diagonals, which gives you 4 triangles. Each of those 4 triangles should total 180 degrees. So then 4 times 180 is 720. If I divide that total sum, 720, by 6 angles on the inside, each angle then becomes 120 degrees. If an inside angle is 120, its outside angle is 60. There are 6 outside angles because there are 6 sides, so the sum of all the outsides is 360. There should be a definite pattern that you're seeing. And the first one says, depending on the number of sides, we're talking about an n-gon now. If there are n number of sides, how do you get the number of triangles? Well, we went from 3 to 1, 4 to 2, 5 to 3, 6 to 4. Every time we found triangles, we took the number of sides and we subtracted them by 2. If we wanted to find out the sum of the interior angles of that particular polygon, we just took the number of triangles that we had, n minus 2, and we multiplied that by 180. If we wanted to find the measure of one of those angles, we took the entire sum, m minus 2 times 180, and we divided it by n. If we wanted to then find the measure of one exterior angle, we need to know something about all the exterior angles. And as it turns out, every single exterior angle, the sum of all of them was always 360. So if you ever want to find the measure of one exterior angle, you just need to know what all of the exterior angles are and divide that by n. Okay, so this is what you're going to really have to know in terms of polygons, and we'll do that on the next sheet. So the back of your notes then just has some formulas to fill out. And that's going to be this. The sum of the measures of the interior angles of a convex polygon, the sum of the interior angles, sum of interior, is always going to be n minus 2 times 180. How many triangles can you create? And then multiply that by 180. Assuming we're working with a regular polygon and you want one of those interiors, then you're going to find out what the sum of them all are, but then you'll divide that by the number of sides. If you want to know the sum of the measures of all exterior angles, not a formula, just a number. All exteriors are always 360. If you want the measure of one of those exteriors, and again, you need to know that it's regular, then you do 360 divided by n. These 4 theorems you definitely need to know, and they'll help you with it'll be helpful for your homework. Okay, good luck on the homework.